This topic is about discriminants and finding an unknown parameter k using knowledge of discriminants. I will go through some examples before a recap on discriminants. So we have three different cases. So when the discriminant, which is equal to b squared minus 4ac, is greater than 0, then we know the graph intersects the x-axis twice. So we have two distinct real roots, so two different real roots. Okay, the second case is when the discriminant, which is b squared minus 4ac, is equal to 0. When it's equal to 0, it touches the x-axis once, so it has one repeated real root. So touches for this example. And when the discriminant, which is b squared minus 4ac, is less than 0, then your quadratic graph does not cross the x-axis, so there are 0 real roots. Okay, so those are three cases, and you need to always think of these three cases and read the question carefully to decide which of these cases it is. So let's go to the first example. Find the range of values of k for which x squared minus 2kx plus 5 equals 0 has no real roots. Okay, no real roots means d must be less than 0. Okay, the function that we have in front of us is x squared, equation, x squared minus 2kx plus 5 is equal to 0. So in this case, a, the coefficient in front of x squared, is 1, b is equal to negative 2k, and c is equal to 5. Which means the discriminant, which is equal to b squared take away 4ac, is equal to negative 2k all squared minus 4 times 1 times 5. Negative 2k all squared is 4k squared, minus 4 times 1 times 5 is 20. Okay, next we need to do is, we know that discriminant is less than 0 in this scenario. So we know 4k squared minus 20 is less than 0. Let's divide by 4, so we get k squared minus 5 must be less than 0. It's a quadratic, difference of 2 squared, which means k plus root 5 and k minus root 5. Do a rough sketch. So it's going through negative root 5 and positive root 5. We want the part that's less than 0, so we want this part of the graph, the corresponding x values at these x values, which means k must be between negative root 5 and positive root 5. Now, if you put this into a calculator, your number is roughly between negative 2.2 and positive 2.2. So that would be your solution. So all the k values for which x squared minus 2kx plus 5 has no real roots. Now, let's look at this problem graphically. So as you can see, this is the graph of the equation, and it has two x-intercepts, so obviously it's got two real roots. We were looking at the problem where it doesn't have any real roots, so I'm going to change the value of k until this graph moves above the x-axis. So you can see as we get closer and closer to 2.2, so at 2.1 you can see it's above, slightly above. If I zoom in a bit, you can see it's above, yeah, at 2.1. So everything less than 2.1 all the way up to negative 2.2 is above the x-axis. And then when it's less than negative 2.2, you're going to see you get x-intercepts again. So our solutions make sense graphically. Let's look at a second example now. So find the value of k for which y is equal to 2x plus k is a tangent to y equals x squared minus 2x minus 7. Okay, now when I see the word tangent, it implies one point of intersection. Which implies the discriminant must be equal to 0. So I've got two equations, y is equal to 2x plus k, and y is equal to x squared minus 2x minus 7. Because they both have y as a subject of the formula, I can equate them. So I end up getting 2x plus k is equal to x squared minus 2x minus 7. Take everything to the right hand side. I get x squared minus 2x minus 2x minus 7 minus k equals 0. X squared minus 4x minus 7 minus k equals 0. So in this case, my a is equal to 1. My b is equal to negative 4. And remember, all that is my constant. C is equal to negative 7, take away k. Work out the discriminant now. Discriminant is b squared, take away 4 times a times c, which is negative 4 squared minus 4 times 1 times negative 7, take away k. Negative 4 squared is 16. Minus 4 times 1 times negative 7 gives me positive 28. And negative 4 times negative k gives me positive 4k, which means I end up getting 4k plus 44. Now remember, from initially I did say discriminant is equal to 0, which implies 4k plus 44 must be equal to 0, which means 4k is equal to negative 44, which means k is equal to negative 44 divided by 4, which is negative 11. Let's look at this problem graphically. So you've got the quadratic and you've got the linear equation. And at the moment, there are two intersections. Remember, we're trying to find out where the linear line is a tangent to the curve. So at the moment, obviously, there's two intercepts, so it's not a tangent. So if I make it smaller, we found out the solution is k is equal to negative 11 is the solution. So let's make k equal to negative 11 and hopefully it will be a tangent at that point. So at negative 11, you can see it touches the curve at one point. So it is a solution to the problem. As soon as it's less than negative 11, it doesn't have any intersections. So it does make sense graphically. Okay, let's have a look at the third problem. Find the range of values of k for which y is equal to x minus 3 meets x squared minus 3y squared is equal to k in two distinct points. Okay, two distinct points means the discriminant must be greater than 0. Okay, so I've got two equations, y equals x minus 3 and x squared minus 3y squared is equal to k. If I have label it 1 and 2, I'm going to substitute 1, which is linear, into 2, which is non-linear. So I end up getting x squared minus 3 times x minus 3 squared. So replace everywhere that I see a y with x minus 3 is equal to k. If I expand it, I get x squared minus 3 times x squared. I get negative 3x, which is negative 6x. Negative 3 times negative 3 is plus 9 is equal to k. If I expand it out further, x squared take away 3x squared minus 3 times minus 6x gives me positive 8x. Take away 27 is equal to k. Okay, if I simplify these two terms, I get negative 2x squared plus 18x negative 27. If I take the k over to the left hand side as well, I get negative k is equal to 0. I don't like a negative x squared coefficient, so I'm going to multiply everything through by minus 1. So I end up getting 2x squared, take away 18x plus 27 plus k is equal to 0. Okay, and in this case, a is equal to 2, b is equal to negative 18, and c is equal to 27 plus k. Okay, remember I need to work out the discriminant. So discriminant is equal to b squared minus 4ac, which is equal to negative 18 squared minus 4 times 2 times 27 plus k. Negative 18 squared is 324. Minus 4 times 2 times 27 gives me minus 216. Minus 4 times 2 times k gives me minus 8k. Which gives me, simplifies to 108, take away 8k. Now remember, the discriminant was greater than 0 in this case, which implies 108 take away 8k must be greater than 0, which means 108 must be greater than 8k. If I divide through by 8, 108 divided by 8 gives me 27 over 2, which is the same thing as 13.5. I'm going to rewrite it the other way around. So k is less than 13.5 is the solution. If I look at this graphically, you can see that the red line, straight line, and the blue curves are not meeting at this point where k is equal to 28.6. So let's make k smaller. So it's still not meeting, and I think as we get closer and closer to 13.5, it should meet. So you can see it's meeting at 2 points. You can see it's clearly there, 2 points. And you can see as we make k smaller and smaller, even when we get to negative values, it's still meeting the blue curve at 2 points. So k is less than 13.5 seems like a valid solution. Now let's go through our final example. It says find the values of k for which y equals kx minus 2 does not intersect the curve y equals x squared, take away 8x plus 7. So does not intersect implies that the discriminant must be less than 0. So we've got y is equal to kx take away 2, and y is equal to x squared take away 8x plus 7. Because they have y the subject of the formula, I can equate the two right hand sides. So I've got kx minus 2 is equal to x squared take away 8x plus 7. So if I take everything to the right hand side, I end up getting x squared take away 8x take away kx plus 7 plus 2 is equal to 0, which means x squared plus negative 8 take away k lots of x plus 9 must be equal to 0. Okay, in this case I have a is equal to 1, b is equal to negative 8 take away k, and c is equal to 9. So if we work out the value of the discriminant, then b squared is negative 8 take away k squared minus 4 times 1 times 9. If I expand the square, I get 64 plus 8k, which gives me 16k plus k squared, take away 36. If I simplify this, I get k squared plus 16k, 64 take away 36 gives me plus 28. Okay, we know in this case the discriminant is less than 0, which implies k squared plus 16k plus 28 must be less than 0. if I factorize this, get k plus 14 times k plus 2. Okay, if I do a rough sketch of this quadratic, which goes through -2 and -14, the part that's less than 0 is below the x-axis, so it's all the x values between -14 and 2. And that would be my solution algebraically. Now if we look at this problem graphically, you can see there are two intersections when k is equal to 3.2. So our solutions algebraically were between -2 and -14. So let's slide this over. You can see currently there is still two intersections even when k is equal to -1. Now when we get to -2, I'm assuming it's a tangent. Yep, so a -2 is a tangent, so it's still not a solution. As soon as it's lower than -2, you'll see there's no intersection. So no intersection still. No intersection still going on. K is getting closer and closer to -14. So at -14, we're expecting it to become a tangent. Yep, it does. At -14, it does become a tangent. So everything between -2 and -14 give us a solution to the original problem. So if it's less than -14, again, there is two x-intercepts. So this does make sense again graphically.